All right, so for our summary chart, we have all of our functions on here. We have absolute value. We know that makes a v. We have the quadratic function. We know that makes a u. And then now we're to the cubic function, which now has rotational symmetry, and it makes an s. Okay, so this is the first function with rotational symmetry. We'll see more of them. But the first two functions had an axis of symmetry. This next one has rotational symmetry. Okay, and so for our transformations, we know that plus 5 outside the parentheses is up 5. And remember, if there aren't parentheses, it's automatically outside. If they wanted them inside, they would have to draw them. We got down 5. And then now here we have parentheses, and so that is inside. So it's inside the crazy house, it's backwards. So the plus 5 actually moves left 5, while the minus 5 moves right 5. Okay, there's no parentheses here, so it's automatically outside, so that's our x. And then it jumps inside, so that is our y, reflection across the y-axis. Can you look awake, please? Okay, and then a 5 outside, vertical stretch by 5. A 1/5 outside, suddenly it's smaller than 1, so we're going to call that vertical compression by 1/5. 5 is inside the crazy house, so that's horizontal compression by 1/5. The 1/5 is inside the crazy house, so horizontal stretch by 5. Same rules, different function. Okay, and so the only transformations that affect the inflection point are moving left, right, up, and down. You actually have to translate it. So you can say translations. Left, right, up, down. And so if I ask you where the inflection point is or the point of symmetry, all you're looking at is the left, right, up, and down. You don't care about the reflections. You don't care how stretched it is. None of that. Okay. Which transformations affect the domain and the range? None. All real numbers all the time. So it's almost like a trick question. If I give you this big, ugly, complicated cubic function and ask you for the domain and range, don't look at anything. You don't care what happened to it. It's all real numbers all the time. It's still an S. Whether I stretched it, whether I compressed it, doesn't matter. Okay? One thing I do want to mention is that a reflection across the x-axis and a reflection across the y-axis result in the exact same graph. Okay, if I take this parent function, this blue function, and reflect it across the y-axis, it's this decreasing backwards s. If I flip it downward across the x-axis, it's still this green backwards x, s. And so if you want to make a note, if I just give you a graph and ask you for the transformations, you won't know if it's Rx or Ry. You only know from the equation whether it's Rx or Ry because they're the exact same. Both result in a decreasing function. Okay, so both, we'll just make that note, both Rx and Ry decreasing. Again, that will be more important next time. Let's zoom in a little bit. All right, so on example 1, if I want the inflection point, I just care about left, right, up, and down. So this is right 7, up 6. So that moves it to 7, 6. They're also asking to list the transformations. There are 1, 2, 3, 4 transformations here. The first one is Rx. Second one is vertical compression by 1/3. The third one is right 7. And the fourth one is up 6. These are the only ones we care about. Okay, so the Rx means it is now decreasing. Vertical compression means it's a little bit shorter. And then we have our inflection point at 7.6 because of the transformations. But none of that affects the domain and range. So we can fill that in all the way down. Oh, that's not asking. Okay. Here, bad form, if we haven't had enough practice with that, we need to factor out that -2. So put your double parentheses. And to figure out what goes there, we have to divide 1 by this -2. So that gives us a -1/2 inside the parentheses. And so if we are listing the transformations, we have an RY now. We have a horizontal compression by 1/2. That -2 is still inside the cube. That's why there's double parentheses. So don't suddenly call it a vertical stretch. And then right 1/2. And then down 7. So we still have a decreasing function with a negative slope here. And then right 1/2, down 7. So x is 1/2, y is -7. Right here, there are no parentheses. That's why I always want to put this example on here, because a lot of people are like, well, is that right for? Is this an RY? Because it's directly on the x. If there were parentheses, they only get to be around the x. And so this is Rx and down 4, only 2 transformations. And so it's decreasing, and it didn't move for the x coordinate, but it did move down 4, so 0, -4. Right, we are writing a function. And so we are reflecting across the x-axis, horizontally compressing by 1/2, left 3, up 11. Okay, and so reflecting across the x-axis means we need a negative outside the parenthesis. Horizontally compressing by 1/2 means we need a 2 inside the parenthesis. Open parentheses. There's no video for this, so if you're leaving, you're going to miss it. Plus 3. For left 3, put the cube. If you don't write the cube, you are not writing a cubic function. And then up 11. Make sure you have those double parentheses, otherwise it's not left 3. What was the question? Okay. All right. Let's graph. Okay, so in order to graph, we're going to use the same trick with the rise and the run, stretching the rise and the run. Only now our rise and run are different numbers. Okay, so this time our run numbers are still 1. Okay, we're still going over 1, over 1. But this time we're going up 1, up 7. Okay, and so your run numbers, which is your change in x, you may see that delta x, is going to be 1 and 1, whereas your rise numbers, your change in y, is going to be 1, then 7. So over 1, up 1, over 1, up 7. And then if it's vertically stretched, that 1, 7 is going to change. If it's horizontally stretched, that 1, 1 is going to change.
I just thought you meant like it would be on 1, 1, 8.
Oh, no, I'm not talking about the ordered pairs. I'm talking about the distance between the points. Okay, so this point is at 8. This point is at 1. And so that vertical change is 7. And so those numbers are what's changing when you stretch a function. Okay, and so here's our examples. Okay, so this one, step 1, let's plot the inflection point. So 1. Inflection point, we'll call that the IP. Inflection point is right 1 up 2. And so plot that. So that way on a multiple choice test, if you're given a bunch of graphs, you can at least narrow it down to the one that has the correct inflection point. Okay. Step 2, decide if it's increasing or decreasing. There's no Rx or Ry, so it is increasing. Okay, and so when we plot our other points, we need to make sure it's still increasing and not decreasing. Yeah. Then it would be back to increasing again. So basically an Rx, if you have both an Rx and an Ry, they cancel each other out and become nothing. But list them both, but just know on the graph you won't see them. Good question. Okay, so this is increasing. And then 3, we have the vertical stretch by 3. And so the change in y's, instead of being 1, 7, we're going to multiply those by 3. It's going to be 3, then 21. So that's going to fall off our graph. All right, so to get our next change in y, we're going to go over 1 up 3. And then obviously over 1 up 21, but we're going to be off our graph. Okay, so get the point on the other side, over 1 down 3. And then make sure it looks like an S. So how you draw the inflection is act like you're drawing a happy parabola connected to a sad parabola. I've seen all kinds of weird twisty things. Happy parabola connected to a sad parabola, and that's how you graph the inflection. And so those 3 points are the only ones that fit on our graph. Everyone okay with that? Okay, example 2, let's go ahead and list the transformations. We have an Rx, so we're decreasing. We have a horizontal stretch by 2, and then we have a down 3. Okay, so step 1, the inflection point I know is going to be 0, -3. So let's plot that, 0, -3. Step 2, because we have a reflection, it doesn't matter which axis it's across, because there's only one, it's decreasing. Okay. And then we have a horizontal stretch by 2. And so our run number, our change in x, is going to go from 1, 1 to 2, 2. Okay, and so make sure you have it decreasing to get to your next point. And so our change in y's are still going to be 1, then 7. That's not going to change because we have a horizontal change, not a vertical. Okay, so we're going to go this way because we need decreasing. Over 2 up 7, up 1, over 2 up 7 puts you at the 5. So this time our happy parabola is on the left. Connected to our sad parabola, we need to go over 2, down 1, over 2, down 7. Just off our graph. Sorry, that was bad. Do yours better. Okay, so it's stretched, so it's a fatter looking S. Everyone okay with that one? All right, let's switch to blue. We've got an Rx. We've got a vertical stretch by 2. We have a right 4, up 1. Okay, so step 1, our inflection point is right 4 up 1. So 4, 1, put that right there. We have 1 reflection, so decreasing. Then step 3, we have a vertical stretch by 2. So the change in x is still 1, 1, but our change in y is now 2, 14 instead of 1, 7, 2, 14. Multiply the y distances. Okay, and so we're decreasing again, so we're going to make our happy parabola go up to the left. Okay, so over 1, up 2, over 1 more, up 14. That's off our graph, so we won't graph it. Go down here, over 1, down 2, and then down 14 will be off our graph. So make a very steep happy parabola and a very steep sad parabola for a decreasing function. More than likely, you'll be given a graph on the test and asked to identify the equation or write the equation, and that's where recognizing these patterns will help. Is everyone okay on that one? All right, here's one with bad form. Okay, this is not right 4. Let's factor out the -2, and it leaves an x plus 2 inside the cube. And so when I'm listing my transformations, I have an ry, a horizontal compression by 1/2, a left 2, up 1. Okay, so step 1, the inflection point is -2, +1, right there. Step 2, because we have 1 reflection, it's about the y-axis, we have a decreasing function. And then step 3, our change in x's, our run changes. And so our change in x goes from 1, 1, cross those off. It is now 1/2, 1/2. I'm going to do 0.5. I always do decimals when I'm graphing. And then the change in y is still 1, 7. Okay? So this time we're still decreasing, so we're going to go up and to the left. So over 1/2 up 1, go over 1/2 up 7. So that'll put you at 9. So again, it's looking very, very steep with that horizontal compression. Okay, over 1/2 down 1, over to the next whole number, down 7, puts you at -7. Another bunch of really steep S's. That's so bad.